Alright, for our next problem, I have A times A, C times C times C over A, C times C times C times C times C. And I'll start canceling. And I notice I have A left on top and two C's left on the bottom. So I have A over C squared. The next problem, I'm going to use a calculator here at first. So I'm going to take 5, let me clear that, 5 times negative 81, or just 81, because I know that's a negative anyways. So I get 405. So I have 405 and negative 405. These two are just y squared t to the fourth over 45 t to the third. So now I'll divide 405 divided by 45, which gives me 9. And I know it's a negative 9 because it's a negative divided by a positive. I have y squared left on the top because nothing's going to simplify with that. And then my t's, I'd be left with a t on top. Now, we really didn't need to use a calculator if you recognize that 9 goes into both 45 and 81. So you can make this 9 and make this a 5. And then what you could do is divide 5 divided by 5 is 1 and 5 divided by 5 is 1. So that's how you can end up with negative 9 without using a calculator at all. On this next problem, to start out with, I had two negatives. And I know a negative over a negative is actually a positive, so I'm going to change it to plus the opposite. So I really have 3 times x times x times x, y times y times y times y, over 2 x times x and y times y. So I end up getting my x's to cancel, my y's to cancel, and I have 3 over 2. I have an x on top and 2 y's on top, so I get my answer to be 3x y squared over 2. The next problem is a power of a fraction property, so I'm going to take each of the parts and raise it to the power. That's what the rule says. If it's divisible, we could go ahead and divide, but these are not divisible, so I'll just say this is 2 to the fourth and 3 to the fourth. Well, 2 times 2 times 2 times 2 is 16, and 3 times 3 times 3 times 3 is 81, so I get 16 over 81. On my next problem, I actually have something that's divisible, so I could just simply say this is 3 to the third power. And then that would be 3 times 3 times 3, which is 27. On the next problem, we have some variables here, so we'll say that we have x to the 6th, 3 times 2, over 2 to the 2 times y, which would just be 2y. I cannot do anything else to those because they're not like bases. The next problem, I've got c to the 2 times 4, which is negative 8. And then I have d to the 12th power, 4 times 3. Again, they are not like bases, so I am finished with that problem. The last few we're supposed to leave our answer in scientific notation. Let's look at this a different way. This is 3 times 10 divided by 6 times 10 to the 6th. Well, 3 divided by 6 is 0.5 times 10 to the, using the rule, 10 minus 6 is 4. This is not in scientific notation because this number is less than 1. So I'm going to change this into standard notation first, which would make this number be 5,000 because it's telling me that I'm multiplying by a large number of 10,000. I noticed that for me to put this into scientific notation, I need to place my decimal right here after the 5. So I'd have a number of 5, which is between 1 and 10, times 10 to some power. Well, it means I'd be moving it 3 places. And so I end up with 5 times 10 to the third. On the next and last problem, I've got 2 times 10 to the 8th divided by 8 times 10 to the third. 2 divided by 8 is 0.25 times 10 to the 8 minus 3, which is 5. I'm going to put this into standard notation first. So I'll be moving this decimal over 5 spots. Whoops, wrong way. This is a positive 5, so I'll be making this number bigger. So 5 spots this way. So I end up with 25,000. 1, 2, 3, 4, 5, 25,000. I need to place my decimal right here after the 2, so I have a number between 1 and 10. So I have 2.5 times 10 to the 1, 2, 3, 4th power is a positive number because I want my number to be just as large.